internet and new technologies change many aspects of our lives. It's actually related to a number of policy areas that we deal with here in the European Parliament. And specifically, in the field of internet regulation, the European Commission will come up with a number of proposals in the next coming months. As I focus on Europe's digital agenda and internet freedom in my work here in the European Parliament, I noticed that these technical subjects are not always very easy for everyone to understand. But without understanding the possibilities of technologies and the basic functioning of them, it's difficult to make well-informed decisions about policies that influence the lives of many Europeans as more and more people in Europe go online.
In the old telephony world, and still in the current traditional telephony world, when you pick up your phone and you call someone, the whole time of your conversation, when both of you have the phone off the hook, that line is busy, and it's used only by you. No one else can use it at the same time. That also means that that line is the way you speak over the line. All of the words come across in one session, in the right order. Nothing is tampered with. It just goes through nicely. And, you know, if you say, this is the famous sentence, Mr. Watson, come here, I need you, which is the first sentence that was ever said by Graham Bell over a telephone line, it just comes through like that in one connection over a circuit-switched network. The alternative to that the internet put in place is called packet switching. A packet, you have to imagine, it's like you have a box, and in there there's smaller boxes, and it keeps on getting smaller. And if you look at that box, it gives different types of information. There's what they call a header, data, and a footer. And the maximum size is usually 1,500 bits. So it's quite tiny that they have to slice it up, each piece of communication. The header gives information about who is sending that communication, where it needs to go, what type of data is in there. Is it video? Is it voice over IP? Is it an email? It also gives the packet number, which is handy if you come at the other end and you have to put them together again. It's nice if they're numbered. The data is the part where your actual communication is. So if you're sending an email, it's the content of your email sits in the data. And then you have the footer, which has mainly two purposes. One, it shows that that's the end of the packet, so that the computer understands, okay, it begins here and it ends there. And secondly, it has some neat applications for error correction, because the problem that you have, obviously, when you throw all of these packets over a network of networks, and that can go across, you know, continents, countries all over the place, is in some case, they drop a packet. A packet gets lost somewhere, or it comes and it's been a bit tampered with by the network, so it's not readable. The footer allows the computer at the end to say, whoops, that doesn't look like a decent packet to me, send it again. And then that packet will be resent by the sending computer at the beginning. Now, this sounds all complex, but this happens in milliseconds. It doesn't even take seconds for all of that to happen and all of those conversations to go.
The reason why probably nobody knows, or most people have never heard about the domain name system, the DNS, or the naming and addressing issues, is for two reasons. First of all, it works, so that means nobody complains, nobody cares. And secondly, it's run by a not-for-profit sector. What you pay for your domain name, if you have one, is basically reinvested in the local internet communities in terms of research and development to work on the next level of the internet. As you know, the internet consists of devices that communicate with each other. I mean, obviously, to do that, they need to know where to find each other. And that means they have to have an address. Currently, we're using two types of IP addresses, version 4 and version 6. Why is this relevant? Because version 4 is running out, and version 6 is being introduced, and it comes with a whole range of technical, but also policy and legal issues. If you would assume that the number of IPv4 addresses has the size of a golf ball, then the range of IPv6 addresses has the size of the sun. So it's clear that from now on we should not be running into any scarcity anymore. So why do you need a domain name if you have addresses which allows the devices to communicate to each other? First of all, nobody is able to remember long IPv4 addresses, let alone IPv6 addresses. So it's easier for people to communicate. It's a mnemonic. Secondly, domain names allow the system to become flexible. If anything would happen in a worst case scenario with the server on which your information is hosted, it would be pretty easy to switch in the domain name system the IP address that is referring to your content. So it makes it more flexible, and it also makes it more secure, since it's easier to distribute packets in case of a server overload, which most of the time would happen through malicious conduct, such as a denial of service attack, basically hackers trying with millions of them to bring your server down.